Okay, welcome back. This is EENG360, and today we're going to do listing 314 out of the textbook, and that has to do with sign magnitude adder. Now, sign magnitude format is a format for, it's not a very popular one, but it's a format for representing negative numbers. The most significant bit is the sign bit, and the remaining bits are the magnitude. So if you come down to here, I've got an example of a 4-bit sign magnitude format. Going from 0, 0, 0, 0 all the way up to 1, 1, 1, 1. Now in sign magnitude format, the most significant bit is the sign bit. So the first half of these guys are positive numbers, the second half are negative numbers. Okay? And then the remaining 3 bits are the magnitude. 0, 1, 2, 3, 4, 5, 6, 7. Here it's 0, but it's a negative 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Now the disadvantage of this guy is that you have a positive 0 and a negative 0. And the hardware implementation is not exactly as efficient as you can do with 1's complement and 2's complement. But nonetheless, it is another way of representing negative numbers. Now when you look at this, if both numbers are positive, if I add 1 plus 2, well, that's going to give me a 3. Okay, that's an easy case. The sign bit is just the same as in both of them. And then if I do negative 1 and negative 2, well, it's a negative 3. The sign bit's not going to change. The issue here is when you kind of do like a 2 and a negative 1. Well, the answer should be a 1. So the question here is that what you can do is you could look at the magnitude of this, 2, the magnitude of this, which is 1, take 2 minus 1 and say, well, let's see, the largest magnitude had a positive, therefore my result's going to be positive. And it is. 2 and negative 1 is a 1. Now in the other case, you can have a 1 and a negative 2, in which case the answer is a negative 1. Well, here you say, what's the magnitude? It's a 1. What's the magnitude here? It's a 2. Okay, so I take 2 minus 1 again, minus 1, but the biggest magnitude has a negative sign bit, so therefore the result, 1, is going to be a negative 1. And that's exactly the algorithm we're going to use. Okay? The sign magnitude adder performs addition and operation in this format. If 2 operands have the same sign, add the magnitudes and keep the sign. Simple as that. The difficulty comes in if 2 operands have different signs. Subtract the smaller magnitude from the larger, okay, and then keep the sign of the number that has the biggest magnitude. So you got to remember the sign. All right, well, that's what we're going to do. So let's go ahead and close this and show you the VHDL of how to do that. Okay, let's create a project. Let's do File, New Project. And let's see, what we'll do here is I am going to browse to let's see, where is all this stuff at? Courses, 452, 362. We'll go to here, and let's see, Chapter 3. We'll put it in Chapter 3. And this guy we'll call listing. What's the listing? It's 314. Okay, so I'll call it 314. All right. And yeah, Spartan 3E, 500E, flat grid 320. Okay, that's good. And finish. All right. So at this point we have an empty project, so we have to do new source. And let's see, let's just call this guy, we call it sign mag adder. Alright, sign mag adder. Okay, and let's see, it's a VHDL module. I'll actually do that manually. Okay. So let's see, we've got some design summary stuff here. Let's get rid of that. And let's take out all the comments so we can just focus on the actual VHDL code. Now, I don't think I'm going to be using any of that stuff. I might be, but I'm not sure if I am. All right. Yeah, let's we'll go ahead and keep that in there anyway. Let's go ahead and put that in there. Okay, so this allows me to use standard logic. This allows me to use sign and unsign. Okay. And I'm not going to use this guy, so let's take that out. And let's put in the entity. Now I'll just copy and paste since I have this already written and we can save a little time. You can pause the video and kind of dig through the steps. But there is my entity. Okay. Notice I have a generic that defaults to n, which allows me to pass it upon instantiation. I've got 2 inputs, A and B, that are n bits both. I'm going to add those. And then I'm going to get an n bit sum at the output. Okay. I'm not really looking at overflow here. Assume that won't be there, but there's my entity. A and B are being added together. I get the sum. A and B are being stored in sign and magnitude format. All right, let's go ahead and create the architecture block. Now I've got some internal variables that I'm going to use. And we will see these in a little bit. Now, I have to get the magnitude of A. I got to get the magnitude of B. Notice those are only n minus 1 bits long, right? Because the most significant bit is the sign bit. Okay? Then I got to get the magnitude, okay? I need to figure out the max and the min, because I basically add those if the sign is the same. I subtract them if the sign is different. So then I need to remember the sign of A and the sign of B, because I use that to determine what the sign of the sum will be. Okay? And then once I have the magnitude of the sum and the sign of the sum, I can put them all together. All right, well, let's kind of put that code in there and see what we can do. Let's go down here, put the body in there, and let's see. A is an n-bit number, but what I'm going to do is take n minus 1 bits, and I am going to convert it to unsigned and put it in magnitude. That's the magnitude of A. Notice it was an unsigned, n minus 2 down to 0. I'm going to take B, I'm going to strip off everything except the most significant bit, convert it to an unsigned, and put it in there. So now I have the magnitudes, independent of sign. Well, what I can also do is strip off the sign bit. Sign bit A, sign bit B. That's just the most significant bit of A and B. So now I've got the individual sign bits. Okay. Well, what I'm going to do is I am going to use a process for this guy. Alright, so I'm going to copy and paste that process in here. And the way that process is going to work, it's going to get called if the magnitude of A or B changes, which will happen if A or B change, because you could have those hooked up to switches, and then if the sign of these guys changes. Alright? And we said if the magnitude of A is greater than B, then I am setting up maximum to be the magnitude of A and min to be the magnitude of B, and the sign is always going to be the sign of the biggest one. So this case right here, magnitude's greater than B, so my sign is going to be the sign of A. If I come down to my else block, my sign is going to be sign of B, because now B is bigger than A. Well, I set up maximum magnitude to be the B term, and then min to be the A term. Right? So I'm basically just looking at the magnitude to figure out what my sign bit should be. Sign bit is always the sign of the maximum magnitude. Okay? And then after that point, let's see, you can come down to here and finish up this code outside the process block with another concurrent statement. You've got this. The magnitude sum is the sum of the magnitudes when the sign bits are equal. If they're both positive, just add max and min. Okay? If they're both negative, just add max and min. But if one's positive and one's negative, we want to take max and subtract min, but then we have to figure out what is the sign bit. Well, I've already done that up here. I've already figured out the sign bit up here. So what I can do is I can form my output, which is sum, and it's going to be the magnitude of the sum concatenated with the sign of the sum. Convert that to standard logic vector, and then you have sum. And there you go. There is your entire result. Okay. You've got your entity A and B, a generic. You've got some internal variables. You figure out the maximum magnitude, the sign of each bit. You figure out whether A is bigger than B or B is bigger than A. That sets up your sign bit. And then you do the actual addition. If they're the same sign, you do this. If they're opposite signs, you do this. And then you put it all together, and there's your sum right there. Okay, let's go ahead and save this guy. I'm down to here. Let's do simulation on this. Yeah, I've got simulation selected up here. And then what I am going to do is check my syntax. And there it is. It works. All right, I'm going to stop right here, and then in the next one, what we'll do is we'll simulate this guy.